of oxygen, 96.9 FM, broadcasting live from the Knowledge Hub, 121, 123 Obafemi Awolowo Way, Okeado, Ibadan. On this note, I will try to do a quick revision of our previous classes before we are going to move on to today's class. Okay, now we've started with physical quantities, and as I said earlier, that physical quantities are all what we have around us. Anything we can recognize, anything we can measure, so we call it physical quantity. And these physical quantities have three classes. The first class of physical quantity is fundamental and derived quantity. The second class is scalar and vector quantities, while the last, which is what we've dealt with in our last class, is dimensional and dimensionless physical quantities. Now, to go with fundamental and derived quantities, we discuss about their units and all these quantities. Under fundamental quantities, we said it is the basis, or we call it the basic, or we call it foundation quantity, in which other quantities depend. So that means fundamental quantities are independent, and we have 7 of it for this class. If we can still remember, I discussed about length, which is measured in meter. We discussed about mass, which is measured in kilogram. We discussed about time, which is measured in second. Amount of substance in mole, and luminous intensity, candela, and the 7th one is electric current, which is measured in ampere. Now we have derived quantities, though that they are those quantities that depend on these mentioned fundamental quantities. And we have the simplest example to be area. We have volume, we have velocity, we have speed, we have work or energy, we have power, we have moment, pressure, and so on like that. We move on to vector and scalar quantity. Scalar quantities are quantities that have only magnitude but no direction. And vector quantities are quantities that have both magnitude and direction. And I've already explained magnitude to you, that magnitude is amount, what you measure. So when you say something is measured up to 3 centimeters, the 3 is the magnitude, while the centimeter is the unit. So now, then we now move on to dimensional and dimensionless physical quantities. On that, we just make 3 fundamental quantity our foundation. So namely MLT, mass, length, and time. And I said then that mass is represented by uppercase M, length is represented by uppercase L, while T is represented by uppercase T. While time is represented by uppercase T. And we discuss about some dimensional quantity, how we can use dimension to get the unit of some quantity. We discuss about using dimension analysis to know the relationship between physical quantities, to convert a physical quantity from one unit system to another, and it helps us to check whether an equation is consistent or not, or we can say dimensionally correct or not. So we cannot use, as I said earlier, we cannot use a dimensional analysis to test whether a physical equation is correct or not. The only thing we use it to do is to test maybe they are dimensionally correct. So that means the dimension of one side of the equation must be equals to the dimension of other side of the equation. And we have some examples. So, and then under that we still have dimensionless physical quantities. So that means if you say a quantity is dimensionless, so what that one simply means is that that physical quantity has no unit. So that means it has no dimension, or in simple terms, it has no unit. And then we have a lot of example. We've dealt with some in the previous class. So now we have tensile strain or strain. We have coefficient of friction. We have mechanical advantage. We have velocity ratio, and so on like that. So now let's now get to this new class now. So today we are still going to another subtopic, which will be our last slide on that is physical quantities, which is a measurement and the instruments used for those measurements. When we are talking about measurement, we think of let's assume that we bought something yesterday and we are buying the same thing today with the same price. Now, if not for measurement, so you cannot tell if that of yesterday, what you bought yesterday, is the same as what you are buying today. So now it's measurement that will allow you to differentiate that one has a reduced amount, or it increased in amount, or is the same amount. So now that's how measurement is very, very important in physics, and we make use of measurement in all our daily life activities. So now under this topic, time and volume. So now let's now get into the class proper. Now by definition, and the last one is to conduct valid scientific experiment. So now when you're not talking about measurement, measurement is expressed on paper as numerical value multiplied by the unit. So what do I mean by that? So let's give some example. So when we have 1.5 meter, that means 1.5 is numerical value and the meter is the unit. And we have some other example like 5 meter, 2.5 kilogram, 30 seconds, 25 degrees Celsius, and so on like that. So if you are talking about, you have to note something. If you are talking about a good measurement, it requires a suitable instrument, correct procedure, and appropriate unit. Those three are key when it comes to measurement. You are welcome back. Let's juxtapose between the old and the new system of measurement. Whereas some system of measurement that we call old still repeat itself for the new system of measurement. So when we are talking about old, we are talking about traditional. We are talking about imperial method or system of measuring of measurement. So now when we are talking about